All right, there are just 2 slides for this section on balancing equations. First slide is just the rules for balancing simple reactions. There are other examples of redox reactions that are way more complicated, but that redox, oxidation reduction reactions or redox reactions are not covered here. This is just simple where you can get your correct answers just by changing coefficients. So the rules for the simple reactions are: number 1, write the unbalanced equation with the correct formulas. So in other words, once you've got the formulas, you're not going to change those. In other words, you're not going to change the subscripts in the formulas. Second, you're going to balance by adjusting the coefficients to the left of each formula only. And then third, most complicated formula has a coefficient of 1. That's a way to start. You can go back and change that later if you want to do that. But you start with just 1, and most of the time it works out. You don't have to change it. 4, start with the least common elements. And those would be the ones that are not carbon, hydrogen, and oxygen. Kind of a general rule there. And also number 5, balance carbon and hydrogen before the oxygen. Oftentimes in reactions, O is in the form of O2, and it's by itself, so you can easily put a coefficient in right at the end of the balancing process. Okay, so here's 3 examples just to illustrate. And I'm going to write them underneath here and look at the details. Okay, so the first one is going to be sodium carbonate. Put red lines where the coefficients are going to be. HCl forms. NaCl plus H2O plus CO2. All right, so we're going to start. You're going to leave the formulas as they are. And now we're going to use 1 as the coefficient for the most complicated formula. That would be a 1 right here. Some students like to put the 1 in. Other people just leave it blank. But, you know, on a test where I'm looking for the coefficients, 1 is usually a good thing to put in there. Not mandatory, but it's easier for grading. All right, then you're going to work with the least common element. So sodium is less common than carbon or oxygen. Sodium and chlorine are both less common. And so I would go with the sodium because you just assigned that as a coefficient of 1. So you have 2 sodiums on the left. You want to have 2 sodiums on the right. Now come back and do the chlorine next. Chlorine has 2 on the right, so you're going to put 2 on the left. Okay, getting close now. Let's see, you don't have any oxygen by itself, so you could do either carbon or hydrogen. Let's see, the carbon there's 1 carbon on the left, so that's going to make it 1 on the right. Then just look at the water. The hydrogen there's 2 hydrogens on the left, so there's going to be 2 on the right. So that should work out, but you should probably check your oxygen as well. So you've got 3 oxygens on the left, and you have 3 oxygens on the right and 3 oxygens on the left. So this works out. You're done. And then sometimes it's nice to make a little list. So sodium, carbon, oxygen, hydrogen, and chlorine. And you could just write it all down here, say left and the right hand sides. There are 2 sodiums on the left, 2 on the right, 1 carbon on the left, 1 on the right, 3 oxygens on the left, 3 on the right, 2 hydrogens on the left, 2 hydrogens on the right, 2 chlorines, and 2 chlorines. So it's worth it to do that sometimes as well. All right, so then the next reaction is benzoic acid, C6, H5COOH, benzoic acid. So I'm going to write it here. C6H5COOH plus O2 forms CO2. Oops, that was an inconsistency there. CO2 plus water. All right, work on that now. So, seems like we mentioned this in an earlier video that when you count the way the organic molecule formulas are written, you got 6 carbons. This is going to be, the C6H5 is that benzene ring. I showed that to you when we were doing empirical formulas. You don't need to know anything about that except that here I'm just pointing out that this is 6 carbons are contained within the ring and the other carbon is contained in that carboxylate group that I showed you earlier. And so the count for carbon is 7, the count for hydrogen is 6, and the count for oxygen is 2 in this molecule. Okay, all right, so we can start with the most complicated formula and give it a coefficient of 1. It has 7 carbons in it, so let's go ahead and put 7 there. Then you have 6 hydrogens on the left, and each water molecule contains 2, so if you put a 3 here, you have 6 hydrogens on the right. The tricky part is the oxygen, and on the right hand side you have 7 times 2 is 14. So in other words, there's 2 oxygens in each CO2, and then you have 7 of them, so that's 14. And then you have 3 here, so it's going to be 17 oxygens on the right. So you've got 2 oxygens here. The 0 looks like a O, but it's not. Or rather, the O looks like a 0, but it's not. And then this part here is going to be the rest, so that means there's going to be 15 oxygens. So you say plus 15 oxygens is equal to 17. So because the oxygen comes in pairs, you cannot just put a coefficient of 15 here. You can't put a coefficient of 15 here. So the way to do it is to write 15 halves. So in other words, 7.5 oxygen pairs equals 15 oxygens total. So 15 halves times 2, because there's 2 oxygens in each molecule of oxygen, makes 15. All right, so then we don't want to leave it that way. We don't want to have fractions in our balanced chemical equation. So in this case, if you just multiply each one of those coefficients times 2, then you are going to have whole numbers for your coefficients. Okay, so this would be your correct answer. Then you want to make a list: carbon, hydrogen, oxygen, and do the count. Left and right hand sides. So let's see, we have 7 carbons in the benzoic acid times 2, so that's going to be 14 carbons on the left. You got 14 carbons in the 14 CO2 molecules on the right. The hydrogen per molecule on the left is 6. Times 2 is going to be 12 because you have 2 benzoic acid molecules. Then you have on the right-hand side, you got 6 water molecules, each containing 2, so that's going to make 12 as well. Looking good so far. All right, then for the oxygen, let's double check on this. So you get 2 of these here, and then you have 30 oxygens here. So this is going to be 32 oxygens. And then you've got on the right-hand side, let's see, 28 oxygens in here, plus 6 more here. 28 plus 6 is going to be 34. So did I make a mistake? Let me see. You got 30 here. Oh, yeah, this is 4. So 2 times 2 is 4, right? That's 34. Okay, so that one's balanced. All right, then the third one is going to be, let me find it here. So we got Fe2SO43 plus ammonia NH3 plus water forms this one is iron, Roman numeral 3, iron 3 hydroxide, or ferric hydroxide. I left the phases out. This is all aqueous here. And all of them are like that too. Aqueous means that the molecules are in water. It's a solution. Okay, and then the last one is, I can never read this in my notes anymore. Let's see, I think it's sulfate. Yeah, it's sulfate. Okay, so this one is going to be ammonium sulfate. Sulfate is -2, ammonium is +1, so you're going to need 2 ammoniums there. All right, so this is the most complicated one. And, you know, which one do you want to use to give a coefficient of 1? You could either use the iron sulfate or the ammonium sulfate, but we'll just go ahead with, you know, it'll probably work out fine either way, but we'll go ahead with a coefficient of 1 on the iron. All right, sorry about that. I had to stop for a moment. So you have 1 on the iron 3 sulfate, and you want to put 2 in front of the iron 3 hydroxide. So there's 2 irons on both sides, or on each side. Then here's a little trick. I like this trick. Because you have sulfate on the left and the only form of sulfur on the right is sulfate, you can balance the sulfates. In other words, if there was SO2 or S8, something like that, then you wouldn't be able to do what I'm going to show you here. But it works out very well that you have 3 sulfates on the left and you're going to have 3 sulfates on the right. Okay. All right, also, well, you can see with the NH3 on the left that it's in the form of ammonium on the right, so you can't do the same thing. So what else can we do here? We get the iron and the sulfate done. Next, we can look at the nitrogen. So, you know, take a minute and think about this next one on the right-hand side. How many nitrogens are there? The molecule has 2 nitrogens because each ammonium group has 1 nitrogen. So it's got 2 ammonium groups. So it's got 2 nitrogens. And then there's 3 molecules. So there's going to be a total of 6 nitrogens on the right. And easily then you can say there's going to be 6 nitrogens on the left in the form of ammonia. All right, next, the last one is water. You can either balance the oxygen or the hydrogen. Might be easier to go with the, either way you look at it, it's going to be complicated. So let's do the oxygen. All right, so the oxygen on the right-hand side, you have 3 hydroxides, each contains 1 oxygen. So there's 3 there. And then you've got 2 molecules. So this is going to be 6 oxygens. If I put the 0 here, it looks like if I put the O there, it looks like a 0, so I'm going to leave it out. All right, so that's 6 oxygens. And then on the sulfate, there's 4, and you've got 3 of those, so that's 12, so there's 18 on the right-hand side. Now on the left, you have, in the iron 3 sulfate, you have 4 for each sulfate, 3 sulfates, so that's going to make 12. And then you want to figure out how many to put, you can put an X there, or a question mark for the water, so the answer is going to be 6. Okay, so that's going to be 6. Now this is worth checking. It's definitely worth checking here. Complicated system. All right, so then you want to put iron, sulfur, oxygen, nitrogen, hydrogen for the left, and for the right. So there's 2 irons on the left, 2 irons on the right. 12 sulfurs on the left. There are, nope, I'm sorry, there's 3. 3 sulfurs on the left and 3 sulfurs on the right. Okay. The oxygen we just said was 18. You want to double check on that. So you've got 12 plus 6 is 18 here. And then you have 4 times 3 is 12, plus 3 times 2 is 6, so you got 18 on the right. The nitrogen is 6 and 6, and then the hydrogen should match as well. You're going to have 18 hydrogens on the left, and you have 3 times 2 is 6, plus 8 times 3 is 24, plus 6 is 30. Did I get that right? Then what am I missing? Whoops. Go back to the left and look at it again. Oh, yeah, I'm sorry. Yeah, on the left-hand side, you get 18. I guess I forgot the hydrogens that were in the water, so there's 12 more. So that's going to make that 30. Okay, that's balanced as well. All right, these are some good examples, and you've got some more on your group activities that you can look at and practice.